Creating triggers. This nugget, which follows hot on the heels of the one we just did on stored procedures, sets us up for the nugget to come, in which we begin a detailed consideration of MySQL security. In this introductory nugget, I'm going to introduce you to an automation and security object known as, you guessed it, the trigger. After we understand the theory behind MySQL triggers, I'll give you the basics on creating, altering, and dropping triggers. Like stored procedures, triggers are implemented not just in MySQL, but any relational database management system worth its salt. Let's get to work. What are triggers? First of all, similar to stored procedures, triggers are stored code modules. What sets triggers apart from stored procedures are that instead of being attached to a database like we learned stored procedures are in the previous nugget, triggers are always attached to a particular table. And as we go along, you'll see why. It becomes very obvious in just a minute. Let's review for a second what stored procedures were. Stored procedures are similar to macros. They're a recorded series of steps, one or more SQL statements with or without additional procedural logic that are meant to encapsulate some kind of procedure that you want to operate on one or more databases. You see, that's a key feature right there. Stored procedures can range not just within a table, but they can go across tables on a single database or even spread across multiple databases and potentially across multiple servers. Therefore, there's a fundamental difference in scope between procs and triggers. Triggers are much more granular, and these activate right there at the table level. In fact, let's take the second bullet point as an example. Triggers activate either before or after particular data manipulation language or DML SQL statements. Triggers in MySQL fire off with insert, update, and delete statements. Now, if you're an expert with Microsoft SQL Server, especially the latest releases, SQL Server 2005, SQL Server 2008, you might be asking yourself, well, what about DDL triggers? That's something that's supported in SQL Server, but not in MySQL. In MySQL, we simply have what are called DML triggers. All right. Now, what can we do with these triggers? We know that a trigger is a stored code attached to a table, and it's code that's going to fire off automatically either before or after somebody being defined as a table user or potentially even a database administrator, executes an insert, update, or delete on that table. Well, some possible actions that you can have happen in a trigger would be to correct invalid input. So if a user goes to put data into a table and you don't have a constraint defined or even available in MySQL that can sufficiently capture and correct that data correctly, sometimes a trigger can come in and perform more robust data cleanup for you. Another common scenario for implementing triggers is to audit or archive deletes. Now, archive deletes is something I mentioned in, I believe, the last nugget, where companies never want data to truly go away forever, where a delete would happen on the base table, but those deleted rows would actually be shuffled over to an archive table. Audit is also another thing. Whenever an insert, update, or delete happens on a table, metadata such as who made that particular action could be recorded on a separate table. This is particularly helpful just to develop, you guessed it, an audit trail to know who did what in the case of liability issues. A third possible action, and then believe me, there's more than 3 reasons to use triggers, would to help in terms of setting default values. Yes, we have the default column constraint, but triggers provide much more robust capability than a simple default keyword, which gives us just essentially a string value. Trigger ground rules. Let's take a look at some trigger gotchas that you may see on your exam, so I'm going to throw in an asterisk up here. As I told you at the beginning of this course, the MySQL exams tend to be a little bit picayune with some of these kinds of things. Triggers are certainly flexible in their code and in what you can do conceptually in a trigger. However, like I said, there's some of these picayune things that we need to be aware of. The first is you can have a maximum of 2 triggers per event per table. Now, that's kind of a riddle right there, or a Zen koan. Essentially, what that means is you can't have 2 of the same exact kind of events on the same table. In other words, we can't have more than 1 before insert trigger. You see what I'm saying? You can have only 1 match of before or after, and then a particular DML statement. Because as you'll see in the next whiteboard, when we create a trigger, you have your scoping command, which is either before or after. This determines when the trigger fires, and then you have the actual DML event that the trigger is watching for, which is going to be one of 3 keywords, isn't it? It's going to be insert, update, or delete. And the flexibility is such that, let's look at this first pairing. We can definitely double up on a DML statement. In other words, we can do before insert, after insert, no problem. But you're not going to be able to do 2 before inserts where each one does a different thing. And before you start thinking, oh, Tim, well, boy, that's a really big deal breaker, you have to remember some of the things we learned in the previous nugget. Remember with stored procedures, all that branching logic I told you about, if, then, else? That's not a problem that you can have only 1 statement or 1 trigger object for a match between, in this case, before and insert. You can create a very complicated, if you want to, trigger that should cover all of your business rules on that table. The second pairing, we're taking 2 different DML statements, and we're just using 2 different conditions, before and after, just to show that we can mix and match those. Some other hard and fast restrictions with regard to triggers is that we cannot use transactions within the trigger code. Now, if you followed my other nugget products for CBT Nuggets, in particular, actually I covered it in both the Certified MySQL Associate and the DBA1 course, we talked about with the InnoDB storage engine, this storage engine and only this storage engine supports transactions where you can use the begin transaction statement and discretely control transactions and rollback, partial rollback, save points, etc. And it's really nifty technology. However, you cannot do that in a trigger. Another thing is that you can't create triggers on temporary or in-memory tables. You can only apply triggers to real live, full-fledged 100% USDA approved tables. Now let's get down to the meat and potatoes of creating a trigger. Creating triggers. Here we get down to the code. And in this sample, which I borrowed from the MySQL reference guide, this will give us an excellent overview of what to expect from the actual SQL perspective. We're going to build on this, of course, in our upcoming demo. Let's begin at the beginning, proceed to the end, and then stop, shall we? That's a little quote from Lewis Carroll's Alice's Adventures in Wonderland, by the way. The very top, we're creating a table to set the stage. This is a table named account that has 2 columns, one called account number that uses the integer data type. The second column is called amount that is standard decimal, so it's obviously storing currency. Very simple table. Second statement, we're creating our trigger. Now this is important stuff, so listen up. The create trigger statement has 4 basic parts. First, we've got the standard DDL, create trigger, and then the name of the trigger. Here it's called int sum. Next, we have either before or after. Remember, this is the scope or exactly when the trigger is going to fire, either before the DML statement or after. Now, let me pause just now because I haven't yet really described the difference between those two. There's some decision making on your part as a database administrator, database developer, on why you would create a before trigger or an after trigger. Now, a before trigger is, logic would tell you, let's say this is actually the DML statement, the insert, update, or delete. Do you want the trigger to actually take action before the MySQL parser allows the command to take place, or do you want the command to take place and then have the trigger fire? Now, if it's a high stakes kind of a trigger where you actually want a block to happen, Like, let's say you want to prevent certain users from making modifications to a table under certain conditions. Normally, of course, you'd want the data to go through. Otherwise, you'd just prevent the users you wouldn't privilege the users to the table in the first place. But under certain conditions, using trigger code, you would want to stop the user from making a certain data mod. Well, in that case, it would make the most sense, wouldn't it, to do that before the action takes place. In my experience, the after trigger is useful for where you want the action to continue. You don't want to actually block the action, but you're more interested in auditing. In other words, let the DML operation complete and let the user get back to work. And then in the background, let MySQL parser and the trigger code take care of copying rows, creating audit entries in a separate table, and so on. So that's your take-home message, at least according to your instructor, Tim Warner. The before trigger is for a block or some kind of proactive action. The after trigger is primarily where you want the DML action to complete, and then you're doing some kind of audit or security-related cleanup. Okay, so after you create the trigger, before or after, your next important keyword is the DML statement. Insert, update, delete, on, and then your table name, because remember, a trigger is always tied to a particular table. And then we have for each row, 3 words. And then after that, let me just put parentheses around it. And these parentheses are mine, okay? Let me undo that actually, because I don't want to throw you off. We do not need parentheses. Let's just say after for each row, you're just off and running. Put on your wings and start flying because you're just coding and doing your thing. In this simple example, we're using a set statement because this is just basically a proof of concept trigger. What you would do, let me come down to the bottom, if you were in the real world, is you would use a begin-end block after for each row and go to town with whatever your business logic would dictate. In this simple example, we're setting a local variable. Local variables are denoted like they are in SQL Server with an @ sign and then your variable name. This one is called @sum, and we're setting the local variable sum to its own value plus whatever we've done in the most recent insert. And then after that trigger has been created and bound to the account table, we're setting the sum to 0 in the session, and then we're performing an insert where we're adding up some amounts, and then we're selecting or rounding up our sum variable. So this is simple. We're going to do something very similar to this in our upcoming demo. We don't need to worry about the logic of it, but it comes back with the value of the sum variable, which reflects the fact that the trigger is taking the sum and compounding it. Basically, it's gathering up for every insert because it looks like we've done 3 inserts here. We've taken 14.98, 1937.50, and then we're minusing 100 and coming up with 1852.48. So that proves that for every one of those inserts, this trigger is performing that addition for us. And then when we select against that local variable, we're aliasing the result as total amount inserted, and there you have it. Trigger maintenance. The first bit of information I have for you, let me save you quite a bit of searching and hair pulling, is that if you have edits to make on an already existing trigger, you might think that since we use the DDL statement create trigger to define the trigger, and we use drop trigger to destroy a trigger, that we would use alter trigger to make changes. Guess what? As of MySQL 5.0 and 5.1, even 5.4, the beta edition that's active as of this recording in October 2009, there's no support for it. Now, frankly, I'm getting on a little bit of a soapbox here. I can't believe it. So the official party line is, if you need to alter a trigger, you essentially need to drop the trigger and recreate it. Well, that's all I'll say about that. Know that for your exam and know that for life. Before you start a 2-hour Google search looking for why isn't there an alter trigger statement in MySQL 5, you've heard it from me first. So this underscores the crucial importance of understanding how to obtain trigger metadata. We need to get the code for a trigger before we drop and recreate it for sure. Now we can go to Information Schema and look at the triggers view, and we also have a show triggers statement, both of which I'll show you in the demo. Also, from a security standpoint, we have a privilege called trigger that grants a user the create, not alter, but create and delete statements for triggers. Now you'll recall this is different between triggers and stored procedures, that stored procedures are invoked manually with the call statement unless you have some kind of automation built into your application. On the other hand, triggers are simply run, aren't they? You attach them to a table and they just go. In our demonstration, we're going to create and test one or more triggers, and then we'll view trigger metadata such that, as I said, if you need to make edits, you can capture the code, copy it off, and then drop and recreate the trigger. Here we are on LinNugget 1, beginning our demo on triggers. To begin with, let me pop open gedit here. I wanted to share some important information with you. One of the most popular reasons for using triggers in MySQL specifically, friends, is to cover up a weakness that many DBAs see in MySQL, and that is the fact that MySQL, for whatever reason, does not support the check constraint. Now, depending upon your familiarity with relational database management systems, check constraints are a deal breaker for many DBAs. In other words, if you don't support check, I'm going elsewhere. A check constraint is a column-level constraint that allows you to filter data input among certain bounds. In other words, you might have a salary column and you want to make sure that salary meets certain criteria. In other words, salary has to be between 20,000 and 200,000. So if a data entry operator were to accidentally type in 15,000, the check constraint would generate an error. Check constraints are great at reducing human error in data input and therefore greatly enhance data integrity in database tables. So the fact that MySQL does not support these constraints constitutes a weakness. The fairly good news is that we can emulate check constraints with some heavy lifting if you understand triggers. Triggers and stored procedures work hand in hand to overcome this limitation. And although in this demo we're just going to work very simply with a simple example because for our exam objective purposes you just need to know the basics of triggers, nothing spectacular, I wanted to point you to this website here at the MySQL.com Developers Forge and definitely work through this example. It's one of the best tutorials I've ever read on using MySQL triggers and stored procedures to get around this limitation in the MySQL code. Okay, so for our purposes, let me pop open a command shell here. You see I've logged into MySQL. I am logged in as root, and we can check that. If you walk up to a MySQL command prompt, you can check a few different ways. You can do a show process list, and I'm logged in as root. I'm currently connected to world, but I'm about to change that focus because for our purposes, we're going to create a brand new database called TestDB. And then I'm going to use TestDB and create a new table called T. Very simple. And this T table is going to have just a single column. Again, I'm not very imaginative. It's called col1, integer data type. And we're now going to create a trigger that's attached to, we'll call this T, let's call it test trigger. It's kind of tough with the two T's. How about test underscore trigger? And we're going to capture this before inserts. Of course, it's going to be on the T table. Feel free when you're working interactively in the MySQL client to use that return or enter key and use as many lines as you want. Unless you use the semicolon, you can enter all day long and use as many lines as you want, and it's all considered a single statement. By the way, especially if you're doing a complex trigger that uses multiple statements, you'll need to use the delimiter keyword just like we did in the previous nugget where we talked about stored procedures. In this simple example, I'm not even including a begin-end block, so I don't need to worry about using the delimiter keyword to change our delimiter from a semicolon to, say, a $sign As a matter of fact, all I'm doing here is a single set statement similar to what we did in the whiteboard, where I'm setting a local variable that I'm arbitrarily calling x, and I'm going to increment this guy to x plus 1. Again, this is a proof of concept trigger to demonstrate that the code works. Of course, if at first you don't succeed, hit the up arrow key and try again. Can you spot what my problem is? It's a simple syntax thing. I have to add for each row before my actual code. There we go. All right, now that the trigger is completed, let's get it to work. First, let's select against @x. You see that it's null because the variable hasn't been set to anything. To get this started, we have to set the variable to at least some numeric value. So I'm going to kick things off by setting @x to 0. Then we'll do some inserts. Insert into t, and we'll do this. Make 3 inserts, and then we'll select @x again. So you see what happened. It took the row count starting with 0, and then incrementally added rows for each insert. So 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3. So the trigger is adding rows one by one, not values, but rows, as I'm adding those rows into the table. Therefore, as you can see, our trigger is working just fine. Let's complete this demonstration with some metadata. If you run show triggers with no other option besides \G to give a vertical display, you're going to get a lot of output depending upon what you have going on. Now, if you're not attached to a database, you'll get everything. You'll get triggers for all of your databases. If you're already using or attached to a particular database like I am, show triggers will be focused on just the current database like I see. Regardless, I always recommend that you do \G to get a vertical row display. The display of the show trigger statement gives you the metadata including the code. The statement is your important row as far as capturing the code behind the trigger name, the event, the target table, the timing, the creation, the definer, and all of that. The other way to go besides show triggers, of course, is the information schema virtual database. And remember, as I told you, we have lots of tables, or technically views, in there, and we have triggers. So if we run describe triggers \G, lot of rows in there, a lot of rows. I mean, a tremendous amount of data. Consequently, my final query is select star from triggers information underscore dot triggers to be fully qualified about it, where trigger underscore schema equals testdb, and we'll get a vertical row display on that. Basically gives us the very same information that show triggers does, albeit with some different column names. We have action statement instead of, actually I forgot what the column was named with show triggers, but it's the same idea. Couple different ways to do the same thing. Creating triggers review. In this nugget, I introduced you to triggers, which perform really nice automation, security, and auditing functions for MySQL tables, albeit with some limitations. After we covered the theoretical overview, I then showed you the practical aspects of creating, I'll put altering in quotation marks here, and dropping triggers. We finished with a demo. At this point, we're ready to start applying our stored routine code in a security context, which comprises really the first half of this entire course. Therefore, let's start wading out of the shallow end of the pool and start getting into deeper and deeper waters. You ready? I know I am. I hope that this has been informative for you, and I'd like to thank you for viewing.